In this section, we will combine several laws we learned to do circuit analysis. So let's think about review what we learned already. Ohm's law state voltage is equal to current times resistance, right? And also you have several more forms of Ohm's law. Don't forget the triangle, Ohm's law triangle. And Kirchhoff's current law, KCL, talk about the total current into a node is equal to the total currents leaving the node. KVL is talk about the total voltage drop along a loop equal to 0. Now let's look at this example. In this example, you have one current source and one 2K resistor, 2K ohm resistor. And the question is they want you to find all the voltage and the currents for each component over here. So first, let's think about the current source has a current 2 milliampere. So the IS, you can know because look at the polarity. The current source, current pointing from here to up, and the IX is opposite. But they are on the same branch. So they should have same value but opposite direction. So that's why IX is negative 2 milliampere. Now think about KCL on this node. There's a node, a big node over here. In this node, based on KCL, current in equal to current out. But there's no current in. So current out is those two summed together equal to no in, so 0. Because IX, we just solved, that is negative 2 milliamperes. So you can solve IO will be positive 2 milliamperes. So we calculated the two currents over here. Now let's think about voltage. For example, consider how to calculate this voltage. You know the current, you know the resistance value. Based on Ohm's law, voltage equal to current times resistance. So you will calculate 2 milliamperes times 2K ohm. Don't forget, milli is 10 to negative 3. Kilo is 10 to 3. Those two multiplied together is actually 1. So you got 4 volts. If you know here's 4 volts, how to get this voltage across here? KVL. When you write KVL, we can pick up a loop. Let's think about this clockwise loop. So the loop meet the positive sign of VO first. So you write VO, but then the loop meet the negative sign of Vx first. So you write VO minus Vx equal to 0. So Vx is actually equal to VO, equal to 4 volts. Now let's look at another example. In this example, we have one voltage source, that is 10 volts, and 2 resistors. The 3 components is connected in series. 2K ohm, 3K ohm. And the question is, figure out all the variables, unknown variables in the circuit. Okay, so Vx is 10 volts. First, we can think about, we can use KVL because this is in series, so we have one loop over here. Based on KVL, you can have V1 plus V2 minus Vs x equal to 0. But the problem is, what is V1, what is V2? Now consider use Ohm's law. Assume the current goes through this branch is I1 and goes through this branch is I2. Then based on Ohm's law, you have the voltage V1 should be equal to 2K times I1. Same thing here, V2 should be 3K times I2. And then if you think about the KCL on node B, then current in equal to current out, so I1 equal to I2. Then we go to KVL. KVL, that's for a loop. For a loop where you start to write KVL does not matter. So let's start from here. Since I go clockwise and when I meet the negative sign first, so I put a negative Vx, positive V1, positive V2 equal to 0. And since I1 equal to I2, so V1 you can write as 2K times I1. V2 you can also write as 3K times I1 because they are equal. So replace V1, V2 by using that expression you got to here. Then you collect the same factor I1 out, and you have 5K here. And just solve this equation, you can get 5K I1 equal to 10. Then divide by 5K on both sides. 10 divided by 5 is 2. And don't forget 1 over K, because it's 10 divided by 5K. 1 over K is a milli, so that's why I1 is 2 milliamperes. Then sure, if I1 equal to I2, so I2 is also 2 milliampere. And then Ix at node A, you can write out KCL, current in equal to current out. Both currents are out, there's no in, so that's why I1 plus Ix equal to 0, no in. And so Ix equal to negative I1 equal to negative 2 milliamperes. Okay. Now we can calculate what is V1 based on Ohm's law. Should be I1 times 2K, same as V2, I2 times 3K. So we can get V1 and V2. Then that's it. We solved all the variables.